Okay, so yeah, we will talk about these. I'm going to save these two for the end. Okay, your other page, there's just with the Thales theorem. There's some practice questions if you want to go through later and see if you can figure out what some of those angles or arc or lengths are. One of the common problems that they typically ask you is, if we know this is a diameter, then I now know C is what kind of an angle?
A
right angle. Now that I have a right angle, what kind of triangle is this?
A right triangle.
A right triangle. Then you can use things like the Pythagorean theorem to find lengths. You could use sine, cosine, tangent if you need. If you had an angle, it all builds onto each other. Exactly. Okay.
You can use those if you know what.
If it's a right triangle. Yeah.
So find the measure of angle C.
Right.
Obviously, it's the diameter because it has that dot, so we could just say, oh, it's 90 degrees.
But then, and so then it gives us the radius, so you can find the whole diameter and so forth. Then it tells you what AC is, so then you could use Pythagorean theorem to find BC.
Then you find AB. Side lengths are, there's only one angle.
It gives you some,
I didn't see that.
Yeah. Okay. So that's just if you want to do some practice. And then the last page has kind of the theorem, the summary. Here's his theorem. There's the converse. And then some that. And then it also gives you some relevant vocabulary. Okay?
Yeah.
All right. Okay, so now the other thing we are going to talk about today. 62A, 62B. This one. Some inscribed angle theorems and its applications. Oh, I have it all stapled together. That's why I was like, there it is. All right. So this is not stapled together. Okay. So we're going to kind of work a little bit, and then we're going to get in and proving why is an inscribed angle half of its intercepted arc. Okay, so that is going to probably be one of the proofs on your test. Okay?
Mm-hmm.
All right, so starting out, it tells me draw point B on the circle so that AB is a diameter. So if I want to make AB a diameter, this
straight line.
Gonna just continue.
That's a radius.
So then it says, then draw the angle AB that. Oh, ABC. Oops, I don't need the third one. Not that one. ABC. This angle. Right there.
That's, OBC or ABC?
ABC.
Oh, boom.
Yeah.
Oh, wow, that's pretty far.
So, which angle now in this diagram is an inscribed angle?
B.
Angle B. Good. It's the same. AB or ABC. What angle in our diagram is a central angle?
Angle O.
Angle O. Let's be more specific. I see two angles at angle O.
ACO.
Not
AOC.
Angle AOC. Is there another one?
BOA.
Yeah, technically angle BOA. Is there another one?
ABC. No.
Nope.
BOC.
BOC, yeah. So we said AOC, so we're looking at this one right here. And then we said BOC, which was the 180 degree, the diameter. And then we said BOC right there, okay? What is the intercepted arc of angle ABC?
AC.
AC. So here, so if I always say like follow, so here's ABC, so there's the V, and then if we follow it up, it creates the arc or the scoop. So that would be the way we label an arc, we put its points, but instead of putting a line segment over it, I put an arc over it, arc AC.
Wow.
What's the intercepted arc AOC?
Same thing.
The
The
AC.
same one, AC.
That's why it's intercepted.
Well, intercepted just means the ones that's between the two ends, the two rays.
Oh, intercepted doesn't mean that they both have it?
No. No, not necessarily. Okay, so it says the measure, so now we're going to look at this. The measure of the inscribed angle ACD, everybody see ACD in this bottom circle?
Yeah.
ACDC.
We're saying this angle right here is X. And the measure of the central angle is Y. They want to know what's the measure of angle CAB in terms of X.
Well, we know that BD is the diameter,
Okay.
and that
What's AB?
A-
I mean AD.
AD or
Uh-huh.
uh,
What kind of segment is AD?
AD is the radius.
Is a radius. What kind of segment is AC?
AC is another radius.
So what kind of triangle is ADC?
ADC is an isosceles.
It's an isosceles triangle because these are both radii, so they have to be congruent. So then what could I label for the measure of angle D?
Oh, X and D are equal.
Yeah, yep,
They have the same angle because
they're the base angles of an isosceles triangle, right?
Yep. So you can label them both X. Then
So we know all three of these have to add up to what?
180.
180. So X plus Y has to equal 180. Or I could say that's 2x plus y equals 180. So let's say let's call the one I'm wanting to know, because let's call it z. What's the relationship of z and y?
well, if those are all radiuses, then
Z
AC
and
is a
Y.
radius and AB is a radius.
Z and
Right.
Y equals 180.
Why do z and y together equal 180?
Because it makes up the diameter.
And it is also a,
Wait, Z and Y. Oh, it's
And it's a theorem of it.
it's a what? What kind of an angle?
It's a right angle.
Not a right angle.
Whatever the straight line is.
Straight line, straight angle.
Oh, hey.
It's a straight angle or a line which has a measure of 180 degrees. Remember that from middle school?
Yeah.
Okay? Half of a circle, 180. So 2x plus y equals 180. Z plus y equals 180.
angles? Angle Z plus angle Y?
Yes, because it makes a straight line.
In relation to each other or in relation to C?
These
Just
two,
ZY equals 180.
these two make a straight line. So they.
Yeah, so if you start
Okay.
at 0, all the
So-
way down, that's a straight line.
What do you notice then? What could you say about this and this?
They are
Uh-huh.
equal.
They have to be the same, right? Because this part right here, plus y equals 180, this part's the same, so I could substitute because these are the same. Those have to be the same, right?
Uh-huh.
So the angle that I would want to know has to be, this angle has to be twice one of those.
Well, if AD is a radii and AC is a radii, and DB is the diameter, so AB is the radii, two radii together.
Right.
Aren't those like equal?
Yeah, but that's the radii. We're looking at angles. Yeah. Okay.
Wouldn't BC be double X, double angle X?
BC,
Yeah, the arc.
the arc. Yes.
Oh.
Yes. Yep. So yeah, we can look at it. That's good. So you said the intercepted arc, right?
Mm-hmm.
This has to be,
2X.
well, we could actually say it's the same, right? Because this is a central angle, right? And the central angle and the arc, so this is equal to 2x, right? That means the arc is
Z.
2x. And then we can see that the inscribed angle is half of that.
Yeah.
Yeah. Good.
Oh, so that's the answer.
Mhm.
Z equals 2x?
Yep.
Oh. Oh yeah, because we don't have any sort of lengths or anything. We
Right.
don't actually have the right number.
So that's what we're showing is, so we could show, so that's one way we can show, that's if the inscribed angle is on the part of the diameter. So that's the easy one.
What are we going to do next?
Okay, so we're gonna do one more. So if you turn the page.
Oh gosh.
So now,
Well,
what if
wait.
the angle is not?
Is O the center?
O is the center. Yep.
So we could make that a diameter.
So we could, yeah. So it says the intercepted arc of COA. I don't have red on me, so I'm gonna color it purple, or you can just darken it. So
That's not right.
this is the intercepted arc CA or AC. Okay.
Mhm.
If I draw a triangle AOC, so here's AOC. Now I'm going to make it into a, what kind of triangle is it?
Isosceles.
Isosceles, because AO and AC are radii.
Because each radii is equal. So
So then what do we know about the measures of angle OCA and OAC? So these two angles.
Oh, they're the same?
They're the same because they're the base angles of an isosceles triangle. So they're congruent because they're the base angles of an isosceles triangle. Okay, so now I'm going to draw point B on the circle, so that way it's on the inside. So I don't want to put it over here because last time O was on part of our inscribed angle, right?
Mhm.
So I'm going to put it where it's like
In the middle.
out here, yeah. Not necessarily out there. I want O to be inside my inscribed angle. And we can notice that inscribed angle also intercepts the same arc, right?
Yeah.
Yeah.
So we said it's the same. It's the same intercepted arc for the central angle and inscribed angle.
For
The central angle and inscribed angle.
for the intercepted or inscribed?
Inscribed angle. Okay. I'm going to leave this here because I need my circle, but it's actually the next question on the next page. So, question G.
Oh, yeah.
Okay, so it says let the measure of angle ABC be X. So I'm going to call this guy X. And the measure of angle AOC be Y. So can we prove that Y equals 2X? And then it gives me a hint and it says draw the diameter that contains points B. Okay? So what I'm going to do is I am going to draw this. Really, and I don't need the diameter, I'm just going to make it a radius. Right?
Uh-huh.
Okay, so let's say, so this guy is X right here. So if I call this little angle up here A, so once again, this is a radius, right? So that means this guy has to be A.
Uh-huh.
And then this angle right here is
2A.
2A.
Why is it 2A?
Huh? Oh, not 2A, sorry. This would be, what's this? All three have to add up to how much?
180
180, right? So this would be 180 minus 2A. Yeah. There it is.
Can't you just divide that all by 2?
No, because I don't have
Oh,
something
yeah.
that it equals on the other side, right? Lost my train of thought. Wow. Okay, so then this angle, so this would also be A right here. Because I cut it in half. I drew it to where it would cut it in half
Uh-huh.
to the center. Okay. So then, so right here I can say X is equal to 2A.
Uh-huh.
Okay. And then because this is a straight line, right?
Uh-huh.
I can say, so now I can also say these two added together make a straight line, which have to equal how much?
What were you pointing to?
Oh, these two?
Like,
And
the
make
two
it-
radii?
Yeah, well, no, these two angles right here,
Y and 180 minus 2. Okay.
together have to make how much?
90.
No,
That's 180.
180. Why?
Because it's
Oh, because it's half of
triangle.
a circle.
It's a
It's
straight
diameter,
line.
yeah.
It's a straight line. So then I could say 180 minus 2a plus y has to equal 180, right?
Uh-huh.
Wouldn't that mean that y has to be the opposite side of 2a?
So no, y would be the same. So if I did minus 180 minus 180, those cancel out, right?
And you get negative 2a.
Negative 2a plus y
Oh, yeah,
equals
y.
0. And then if I add this over here, y is equal to 2a,
Okay.
right?
Yeah.
That's not right.
That okay.
It looks right.
Could you
When you
you could
change it.
subtract y and get 2a is equal to negative
Why
y.
is this not working out? Like in my head, I see what I did, but I don't agree with it.
Wait. The math is right.
Yeah.
Like
Huh?
the math is right.
Right. I think what I did, so let me try this. Let me try this again. Mark where that right's clear.
So
I know what it's. All right. I know what it should do. All right. So we said these two are congruent with just that part. So I'm going to draw it. So from B through A, all that. So what I'm looking at, so I have, here's this angle, right?
Uh-huh.
This coming up.
Uh-huh.
Okay, so this is B, this is C, that's O, and this is A. So then if I drew that through this, so this whole thing is X, and then I call this A and A. Does that make sense?
Uh-huh.
This whole angle is Y. That's what the issue was. Y wasn't up here. Y's the whole thing.
okay.
That's where I went wrong. Everybody tracking with me now?
Yeah.
Okay. That's why, because I had Y as just this part, but it's not. Y is that whole central angle.
That's weird.
So if this angle is A, that means this angle is
A.
A. And then this is 180 minus 2A.
Why is angle CA though?
Hmm?
Why is angle CA?
Because
the radius.
This is a radius and this is a radius. Right?
Uh-huh.
And then if both of these are a radius,
All radius.
then we'll call this guy right here. So this piece right here has to be 180 minus this, right?
Mhm.
So this would be 180 minus 180 minus 2a, so that'd be so that ends up just equaling 2a. Here we go. Everybody tracking with me?
Uh-huh.
Because this would be minus, and then minus and negative would make that positive. And then this one, so this is not necessarily cut in half. This would be B, which would also make this one down here B. And then this would be 180 minus 2B.
Uh-huh.
Which means this part right here is 180 minus 2B, which is 2B. There it is.
Divide both sides by 2.
So,
yeah, B equals it.
So now we can look and see X right here. So this guy was X. X is a measure of A plus B. Y is this whole angle right here. Y is the relationship of what?
Of 2A.
2A and
2B.
2B. So then if I factor out a 2, so that'd be y is equal to 2 times the quantity of A plus B.
Mm-hmm.
Does that make sense?
Mm-hmm.
And then I can substitute what is A plus B the same as?
A plus B.
No?
It's X.
X.
Oh,
A plus B is the same as X. So Y would equal the quantity of 2X. So if this central angle is 2X, and the arc it makes, so then that makes arc AC equal to 2X. And then that makes angle B
Equal to X.
equal to X. I kept looking at my proof and I was like, that doesn't look right. It's like I can't just assume that it cuts in. Yeah, I don't know why they told us that these are equal. We really don't need to know that. There it is.
Yeah, I want to trade you chalk.
So it's just going through. We divide it into two triangles. So it's saying these two are the same because all three of these add up to 180. This is 180 minus these two, right?
Mm-hmm.
And then because this is a straight line, this is 180 minus this, which just gets me back to the 2A. Okay? And then the same thing over here, except for these are different angles, so we call these B. 180 minus 2B. To make a straight line, we just make these 2B. And so then we get together Y is this amount and X is that amount. Okay. All right. So the next part of these, like example 2, is just another kind of proving the center when like the center of the circle is outside the inscribed angle. We're not going to mess with that. Okay. Everybody got this written down? Sometimes you just got to start over.
Tiny, right?
Okay. So we're going to skip example 2. There's some just questions, like I said, some practice questions if you want to practice finding some different angles later. All right, so the last thing we're going to look at that I told you was the properties of inscribed quadrilaterals.
The trapezoid.
Not necessarily. Okay, so right here, inscribed quadrilaterals. Okay, so let's look and see. So if I pull up, by the way, this link that I'm using for the GeoGebra is on Summit. It's under lesson 2, this interactive inscribed angles in a circle. That's what's taking me to this right here. Okay, so they call it a cyclic quadrilateral. Okay, so what that means is it's a quadrilateral inscribed. Notice all four vertices is on the circle, okay? And so I can pull these around, it doesn't matter, okay? So if I pop up the angles, do you notice a relationship between any of the angles?
2 are blue.
Yeah, 2 are blue, 2 are blue.
Okay, what
Which-
else?
Each, like the 2
Oh,
blue
they-
ones equal 180.
yeah, And then the 2
90,
green ones
yeah,
equal
180.
180.
Okay, so the ones that are opposite from each
So they
other.
all equal 360.
Okay, so all 4, that's always true for a quadrilateral, they're add up to 360. But when it was inscribed this, so let's see if it's true. If I move this one, it changes these 2. Do they still add up to 180?
Yes.
Yes. But if I move these guys,
Yikes.
huh?
Yes.
Yes. Right?
Yikes.
So I can move these. It's making my circle bigger or smaller, whatever, but okay. They will always, so that is true, that they're always going to be, and because what ends up happening is when they're opposite of each other, the way that the inscribed angles work is, notice they make the 2. So these 2 make, so let me draw it 2 different colors. So if I follow this guy right here, makes this part, right? But it would be half of that. And then this guy makes, wait, where's the opposite? So here's his opposite, right? So it goes from C around to
E.
E.
So why doesn't it go to D?
Oh,
And
This
the
guy
purple
goes
one
to-
E.
there it goes. Does that make sense?
Yeah.
So this guy goes to this arc, CE. This guy, and so together they make the full circle, 360, right?
I
But-
already get it.
Okay, let me show you what the difference.
Which 2 points go to?
Okay,
They're
So,
just inscribed
let's-
angles.
right,
You
yeah.
Follow each angle.
so let's look at angle C. Okay, so if I follow it to its, so here's one point, right? And if I follow it the other way, there's its end point. So its ice cream scoop is this, right?
Oh, I get it.
Okay.
From that starting point, we're going to
Uh-huh.
these 2, and then from E, you're going.
So now the angle that's
To D.
opposite is here. So if I follow E to the end, so it goes from D all the way around to B. So notice the 2 intercepted
Yeah, yeah.
arcs together make a full circle,
Oh,
which is 360, right? So then half of that would be
180.
180. So the arc plus the other arc makes the full circle, which was 360, right? The inscribed angle plus the inscribed angle, those are going to be half of that, which is why they add up to 180 degrees. We want to go,
What is that?
so what's our rule? What do we now know?
Last one. Oh,
No.
second one.
No, we're on this, back to here.
Oh.
Back to the properties circle.
Okay.
What is my rule? So let's draw an inscribed where it's not obviously. Keep trying to not make it an obvious trapezoid. There we go. There we
Yeesh.
go.
And that game.
So we know the opposite angles. Is there a fancy word that means
I'm gonna assume there is.
there is. Supplementary. So A plus angle C would have to equal 180, and angle B plus angle D would have to equal.
Wow.
Okay?
So I get it. Starting at point B, the two lines that make that
Mm-hmm.
from like C,
Yeah.
that's super tiny, so it's
Mhm.
gonna go all the way to
Mhm.
A. I get it now. That was just a little confusing.
All right. And then our last property is for parallel lines and intercepted arcs.
We're gonna have to figure anything out for the trapezoids.
If it's a trapezoid, it's not true. It's not. That's not a trapezoid. It's just any quadrilateral. So it works for squares, rectangles, any quadrilaterals.
Okay.
Okay. So parallel lines. So if I have two parallel lines, then the arcs in between them are going to be. What do you think?
Supplement.
Nope.
Just equal.
Just equal.
Equal.
Oh.
Okay. So, and it could be, I don't know if I can pull these, but yeah, so it doesn't matter like how far out, see, they'll change, but notice they're still the same if they're parallel. That makes sense? So I could pull this one like
Whoa.
all the way in here, and they're still, as long as the two lines stay parallel, the arcs in between them are going to be congruent. Does that make sense? So our last one is the arcs between the parallel lines are congruent. If I draw. So these two lines are parallel. So if I call this AB, CD, then arc AC and BD would be congruent. Okay? Okay, questions?
Wait. AC arc is congruent to B.